Hello again, this is Mr. Kusaj, and we're up to lesson 8.4. Don't forget the date up here. And the title is Vectors in 3D Space. So all this time we've been talking about vectors, but if you noticed, they always came with like two numbers, across, and then up and down. Well, now we're going to include the third dimension, so that means three numbers are going to be involved. So coordinates in 3D not only have x and y, they also have z. So three coordinates. So it'd be one for across, left, right, one for up and down, and one for in and out, right? In and out, going back, coming in, going back, right? That's 3D. This is across, this is up and down, and this is in and out. Three numbers, right? So some people find it hard to draw it, but do the best you can. So picture a corner of a room, the floor of a corner room, right? So there's the corner. So if you're looking at the corner, this would be across, right? This would be up and down, and this would be in and out. Okay? So you got to get used to this, but in 3D coordinates, this direction is the y direction. Up and down is the z direction, and the in and out is the xy direction. Right? So some teachers I've seen, they've shown their students with three fingers. So if you look at z and y this direction, then the third number, the x number, right, would be coming towards you, right? So there's the corner, flat, and then coming towards you. Okay, do the best you can in the drawing. So and what I did was draw a box so you can see it a little better. It's coming towards you. Okay, so let's practice this. So let's practice plotting a 3D point. So where would this point be? Okay, where would this point be? 4, 6, 2. Right? This is x, so this is in and out. So, by the way, coming back here, obviously, right, for the z number, up is positive, down is negative. For the y number, right is positive, left is negative. For the x number, the in and out, forwards, towards you, is positive. Away from you would be negative. So this is all positive. So 4 towards you, 6 to the right, and then 2 up. So first thing we're going to do is, draw. First I'm going to do it really sloppy. Underneath here I have a neater one. But basically, right, here is the z and the y, and this would be the x coming towards you. And that'd be going back, right? So we want 4 for x. So 1, 2, 3, 4 coming towards you, right? 1, 2, 3, 4 coming towards you. Then 6 across, right? So now we go from here, we go 1, 2, 3, 4, 5, 6 across. And then we go 2 up. 1, 2. So here's the bottom, right? Here's the bottom. 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. That's the bottom. And then we went up 2. 1, 2, right? So that's 2. And that would create a box if you wanted to do it. So we went this way on the floor. Then we got up off the floor for the z, right? For the 2. Okay, again, right? It's a little hard to draw if this is the first time doing it. Do the best you can. So here's the z up and down. Here's the y across. And here's the x in and out, right? So we did the 4 first. I came down here. And then on the floor, right? We're on the floor of the room, right? So we went 6 across, 1, 2, 3, 4, 5, 6. And then now we get off the floor, up the Z direction, 1, 2. We don't go back here and go 1, 2, right? We're over here, right? And then if you draw, it should be a perfect box where it's 4 by 6, right? The bottom, and then 2 up, if you wanted to draw a box. Okay? I don't know if you've seen this before last year, but this is three-dimensional plotting of points. Okay? Let's move on. Distance and midpoint formula. Good news. The good news is it's exactly the same as it was for xy for the two-dimensional, but now we just add the z coordinate, the third dimension. It's exactly the same. For example, remember the distance formula? This was the distance formula, right? Subtract the x's squared, subtract the y's squared, add them, square root. It's the same exact thing, except you add the z's. For midpoint, do you remember what you did for the midpoint? Add the x's, divide by 2, comma, add the y's, divide by 2. Well, you do the same thing, but you keep going and do it for the z's also. Okay, let's practice that really quick. Find the distance and midpoint between these 2 points, between A and B. So A is here, B is here. Are we going to have to draw this? No. Now we have the formulas. We don't have to draw it. So we're just going to use the formulas. First, let's find the distance, right? So what is the distance? Subtract the x's squared, subtract the y's squared, subtract the z's squared, add the answer, square root. Just look up here, right? There it is. Okay? Do the math, and it comes out to 101.98. That's it. That's the distance formula for 3D coordinates. You're just adding on z. For the midpoint, right, add the x's, right, add the x's, add the y's, add the z's, just like the formula says up here. And then divide by 2, right? And then comma, because it's a point, midpoint is a point. We don't add them, right? So the midpoint between A and B is this point, which we'll call M for midpoint. It's 40, 52, 40. You can do the math. It comes out to 40, 52, 40. Okay? So if you know that, then vectors is basically an arrow. So instead of just a point, you're going to connect the point with an arrow, and that'll be your vector. So remember vector symbols, right? These are the vector symbols. So now the vector in 3D, we're going to start at 0, 0, right, in the corner. And then we're going to go 3 towards you, right? 3 towards you, 3 towards you. And then 4 to the right, and then 2 down, right, beneath the floor, 2 down. Okay? So really quick, where would that point be? Let's get the focus here. Okay. Focus. All right. So where would that point be? So again, right? Here's the corner of the room. Right? That's the other. So here's the floor, right? And here's going up, right? This is the floor right here, right? That's the floor. And that's underneath the floor. That's behind the back wall, right? That's behind this wall, right? So the best way to draw it, I would say, is just the positives, right? So this is the back wall, and this is coming towards you. And this is the floor here. So remember, this is Z, this is Y, and this is X. So 3 towards you. 1, 2, 3. Now from there, 4 across. 1, 2, 3, 4. Now you're here, right? So you came right there, right? 1, 2, 3, 4, right? You don't go back to the beginning here and go 1, 2, 3, 4. You go 3 and then 4, and now we want to go down 2. So we don't go up 2, we go down 2. 1, 2, right? 1, 2. So if you want to create a box, I guess this would be the top of the box, and it'd go down 2. The box would go down 2 like that. Down 2 like that. Something like that. Okay, wait, where's the vector? Well, if this is the point, then we started here. So from here to here, that's the vector. It's going down a little bit, and it's coming towards you a little bit. It's in 3D. So do the best you can, but there's a more accurate graphing of the vector, right? So 1, 2, 3 towards you, 1, 2, 3, 4 across, and then 1, 2. Put a dot there. That's where the point is. That's where it ends. So it starts here, ends here. There's the vector 3, 4, negative 2. There it is. I found it. I drew it. Okay. So we can keep going with vectors in 3D. Find the component form and the magnitude. So if I give you 2 points, if I say the vector goes from here, it doesn't start at the beginning 0, 0, 0, right? It starts here and it ends here. So what's the component form, right? With the V-shaped brackets and the 3 numbers in the middle. Do you remember that? You subtract, right? The end minus the beginning. So 3 minus negative 4, 6 minus negative 2, negative 6 minus 1. That'll give you the components, right? Do the math, and that's my vector. Okay, I found the vector components. These were points. These weren't vectors, right? This is the vector. If you go from here to here, this is what you did. You went 7 towards you, 8 to the right, and 7 down. And then you drew a vector from here to here, but that's what you did. What about the magnitude? Well, the magnitude is simply the distance, right? Remember the bars? That means magnitude. So a squared, b squared, c squared, right? Before, when we were two-dimensional, we just had a squared, b squared. So this is a squared, b squared, c squared, right? So we have the components. You square them, you add them, take the square root, do the math, and trust me, it comes out to 12.7. Okay? Lastly, and this is also intuitive, meaning it makes sense. You don't have to memorize anything. Operations, adding, subtracting, multiplying, dividing, etc. Right? Exactly what you think. So if I wanted to add these two, you add the first numbers, add the second numbers, add the third numbers. Right? If I want to add 2y plus w, then 2 times everything in there, then add it to here. Here are some examples. Find 4y plus 2z. What that means is 4 times this plus 2 times this. Right? That's what I wrote down. So first, I'm going to multiply, right? Multiplication comes first. Multiply in the 4, multiply the 2 in, and get that. Now I'm ready to add 12 plus negative 4, negative 24, right? And trust me, these are the answers you get. Okay? So, very easy. It's just exactly the way we did two-dimensional with 2 numbers. We just extend the same rules and the same formulas to accommodate a third number, the z number. Okay? So that's it for part 1 and for part 2. There is no part 2. Everything is in here. That's all I want you to know for 8-4. But why don't you try it? Try plotting. That's I think is the hardest. Try plotting these 3 points, these 3 numbers, right? Think of your not social security, your school ID, And the last 3 digits of your ID, whatever they are, try and plot that point. So I guess they're all positive, so you don't have to worry about negatives, right? Okay, see you in class. Bye-bye.